All right, good morning, everyone. It's 10 o'clock, so we will get started. Welcome to the March episode of the National Road Research Alliance Research Pays Off. I want to thank everyone for being here in these uncertain times. Hopefully you are all staying safe and staying healthy. I want to just remind everyone to keep themselves muted during the presentation. If you have any questions during the presentation, feel free to type it into the conversation box on the side, on the left-hand side, and we can come back to it during the question and answer time. Otherwise, keep yourself muted. You may be wondering about the pavement workshop scheduled for May. We are currently discussing what to do about that. More information will be announced as we have a decision and more details to offer on that. So no updates as of right now. This recording will be available later this week if you wanted to come back to it at all. Or have to miss a portion of it. It will be available on our YouTube, and the link will be posted to our webpage. And next month, we will be hearing from Monik Barman of the University of Minnesota on performance benefits of fiber-reinforced thin concrete pavement and overlays. And that is scheduled for April 21st. And I will go ahead and introduce our speaker for today. We have Heidi Olson joining us from Braun Intertec Corporation. Heidi has worked at Braun Intertec for over 5 years in the pavement consulting group. Part of her work has included performing countless pavement surface condition assessments for both concrete and asphalt pavements. She was partially involved in this PCC partial depth joint repair project when it began in 2017, and then took over the role of principal investigator in 2019. So she is deeply involved with all the goings on of this project, and we are looking forward to hearing what she has to say today. Heidi, I will turn it over to you.
Thanks, Lauren. First of all, happy St. Patrick's Day, everybody. Try to keep it positive a little bit. So yeah, I'm Heidi Olson. I work at Braun Intertec as a pavement engineer. So as Lauren said, I've been really involved in this project since last year. I did get to see a little bit of it when it started up in 2017. But yeah, now I get to run the show, so that's pretty exciting. So the title of this research project is the Effective, Long-Lasting Partial Depth Joint Repairs for Challenging Conditions. So typical research project, of course, the name has to be a mile long. So really, it makes pretty good sense, though. Effective, long-lasting, partial depth joint repairs. So we're just looking for partial depth joint repairs for concrete pavement that it's going to be effective, it's going to last a long time. But so the question might be, why is it just for challenging conditions? So being that this research is being performed in Minnesota, there's definitely some challenges. First of all, patching a roadway quickly and effectively while avoiding disruption to traffic as much as possible. That's really the perfect trifecta. We want to do it quick, we want to do it well, and we want to do it cheap. And in the process, try not to piss off too many people on the road. Challenge number two, it's Minnesota. So the weather is unpredictable, so there's frequent and severe freeze-thaw cycles. And it also means harsh working conditions. So the objective for this project was to provide a guide for the NRA members and other agencies to establish an effective partial depth repair program for concrete pavements. So to complete this objective, first of all is considering the cost to place the material. So what would be the cost of the actual patching material? Can we use equipment that is already on hand, or would it require new equipment? How long does it take to mix and place the patching materials? How long does it take to cure? So to complete this part of the objective, we documented the installation of the patches, and then we also collected material data sheets of each of the materials. And then the other way to complete this objective is to measure how long do the patches last. So to do this, we are documenting the performance of the patches over 3 years. So a little bit of background for this project. The patches were placed on the old I-94 westbound lane, so just adjacent to Min Road. They were placed in late September and early October of 2017. And the distresses were created using a milling machine, which we were then going to patch. And we did this along 15 test sections on that old I-94 westbound lane. And we used 16 different cementitious and polymeric patching materials. And then 2 of the test sections, we just did the typical HMA patching for comparison. So this is a map of what types of distresses were created for each test section. So each section isn't laid out exactly the same, but each section has each of these distresses within it. So there's the center line, which is the gray, the mid-lane joints, which is the blue. We've got the center line joint, the green, the corner ones, which are yellow, and then the full length for each lane, that's the black and white, and then the mid lane is purple, which we realized this might not fit into the title of joint patching, but kind of another experiment within an experiment, I guess. Seeing how the materials do when it's not in a joint versus on a joint. And then lastly, the wheel path. So for our documentation during installation, so we tried to keep track of a lot of different things at once. So noting how the material is packaged. Does it come in bulk, or does it come in smaller packaging as well? How it would need to be stored. What type of equipment would be required for mixing the material and installing the material and curing the material, and then the procedure for mixing it and installing it, and then curing time. So it's kind of a lot of things that all got collected as these patches are being installed. So the plan right now is to create an installation matrix for the final report, so that we can compare each of the products based on each of these topics, which I think this will be important when choosing products, so that if there's a favorite, or if on a case-by-case basis you might need to use a different product, there might be one that would be better for we need the road to be open as soon as possible. So we just need something that has a really easy to install, really fast curing time. While another one might be better for, maybe you've got just one guy that's able to go out there and do the patch. So something that's easy for just one person to do. So that the hope is that we can create a matrix to kind of help make these decisions. So every research project, you plan it out, you think it's just going to go perfectly, but there's always a couple of inconsistencies. So just wanted to list a couple of them here. So the first one during the installation, the milling process ended up being a little bit more aggressive than intended. So the distresses were a little bit larger and deeper than what was originally imagined, I guess. So because the distresses were so large, there actually ended up being sort of a lack of material. So you may have noticed I said there was 15 test sections. 2 of those were hot mix asphalt, so that means there was 13 test sections with 16 different materials. So because of that lack of material, some of these test sections actually were cut in half, the driving lane versus the passing lane, so that we could use product on each side before running out of material. And also because they were some of the larger patch areas, like the full length that goes across both the driving and passing lane, because it was already such a large distress, the milling process may have cut it deeper in some areas to the point where in a real life scenario, this may have been considered for a full depth repair instead of just a partial depth repair. The other inconsistency, some of the distresses got sandblasted before they were patched, while some didn't. So all the distresses were cleared. They were all air blasted. We had a leaf blower. They got blown out, so there was no debris. However, they were not all sandblasted. The plan was to start out with this, but the process was taking up too much time, and we had a lot of people out there, a lot of products that needed to get placed within just a couple days. So the sandblasting ended up getting skipped over a couple of the test sections to where they could catch up again. So the first test cell, I think the first couple test cells got sandblasted, and then at the end we were able to go back to sandblasting after they were able to catch up. And then the last inconsistency during installation, the patches were not all placed by the same crew. So some of the patches were placed with the help of the product vendors, especially ones that used a little bit of different equipment, had a little different process than typical, just a typical concrete or hot mix asphalt patch. So some of them had the help of the product vendors. Some of them were placed by the MnDOT district crew, and then there were some that actually had some of the NRRA and MnRoad personnel helping out. So it's not necessarily that it could affect anything, it's just an inconsistency. Figured it should be noticed or noted. So after the installation was complete, we actually did a literature review. So just kind of went through some other previous research projects that have been done on patching concrete pavements and partial depth repairs. And some of the things we were looking for was just what are the different types of materials that have been used for the cementitious, polymeric, and bituminous patches. And then also construction considerations, the process of removing the deteriorated in-place concrete, processes for mixing, the placement, compaction of the patch material, and then also the finishing and curing. And finally, we also were looking at the different patch performances. So our conclusions from this literature review were partial depth repairs work well for certain spalling distresses that are within the upper 1/3 to 1/2 of a slab thickness. And when I say certain spalling distresses, it's spalling distresses except for those caused by dowel bar misalignment, working cracks that have been caused by shrinkage, fatigue, or foundation movement, durability cracking, and material-related problems such as ASR. We also found, so construction-related factors can result in premature failures, which is not surprising. And then a well-constructed partial depth repair can last 3 to 10 years or more. So that's assuming that it's been mixed properly, placed properly, the distress was properly cleaned, cleared, debris removed. So if all of that was done properly, that they were showing that these repairs could last up to 10 years. So the next step was site visits. So after installation, we performed site visits for once a year for 3 years. So the patches were installed in fall of 2017. We had our first site visit in June of 2018. So we noticed that the patches actually had held up pretty well through the winter and freeze-thaw cycle. So then the question kind of became, well, I wonder how they would do under the summer traffic with everyone going up north. 94 is a very heavily traveled road. So we decided we were going to do a second site visit within that first year. So we went back in September of 2018. And this is where the patches actually did start to show a little bit more distress. So then the question kind of was, well, or the thought is maybe these are going to be more affected by traffic rather than the environmental effects in cold winters. So during each of our site visits, we were taking photos. We took a lot of photos during the installation of the patches. However, there weren't that many photos of like what the patches looked like immediately after installation. And then during this first year, these two first site visits in 2018, photos were only taken of the patches that were showing distress. So if we don't have a photo, that actually means that the patch is doing well. So then continuing on, year 2, we did a site visit in September of 2019. And during this site visit, we decided we needed to start taking photos of every single patch. So starting 2019, we have a photo of every single patch. And 2020 will be the third and final year, and we will do the same thing with taking photos of every single patch to really show that comparison of how the material is doing over the years. So yeah, we have a couple of photos from installation. We have photos from the first year and photos from the second year right now. We still need to do our site visit for 2020, which will be done this summer. So a couple more inconsistencies. So over these 3 years, as these patches might fail, we need to be repairing these so that we can continue to have traffic on the roadway. So Min Road does repairs when Old 94 westbound is closed to traffic. They will do their own repairs, and that way they can kind of keep track of what's going in and what's going on with each of these patches. However, when the roadway is open to traffic, it's my understanding anyways is that the district takes care of the repairs. So as I had stated before, most of the distresses seem to be popping up when there is traffic on the roadway, which means that the district ends up doing a lot of the repairs out there. So we are still gathering that data about when repairs were done on some of these patch areas. So, you know, we went back out in 2019 and realized that some of these patches have been repaired, but we don't necessarily know when that patch failed. But yeah, so before we look at the comparison photos, I wanted to go over this condition rating scale. So Braun and the NINDOT personnel developed this rating scale to use when reviewing the patch conditions. We decided we wanted to create another matrix that would be for comparing the patch life to include it as part of our report. So the scale is just based on whether the original patch still exists, and if so, what condition is it in? So this is based, so we only were doing the condition rating for the cementitious and polymeric products. We didn't review the hot mix asphalt patches on a rating scale. We were just using those for comparison. So we used the MnDOT Pavement Distress Identification Manual for concrete pavements to define our distresses within the patches. And one quick note is that you can see in the rating for a 4 that we are allowing shrinkage cracking to be present. So shrinkage cracking is not identified as a distress in the MnDOT Pavement Distress Identification Manual, but you know it's a common occurrence in concrete pavements and concrete patches, but it is not considered to decrease the integrity of the pavement or the patch. So yeah, as I said, the plan is to have a condition matrix in the final report to compare the patch life of each product. So we are tracking, so each year, assuming, you know, immediately after installation, each patch had a rating of a 4. And then we are tracking the year 1, year 2, and year 3 condition of the patch and giving it a rating to compare throughout the years. A rating of 4 means that the patch is still in excellent condition. 100% of the patch is still intact, and there's only shrinkage cracking present. The rating of 3, it's in good condition. There might be some cracking or debonding present, but there is still 100% of the original patch in place. A rating of 2 would mean that there's less than 50% of the original patch has been replaced or is gone. And then a 1 would be over 50% of the original patch has been replaced or is gone. And then a 0 would mean that the patch has failed. The original patch no longer exists, or the entire patch needed to be repaired. All right, so looking at each of the products. So this first one in the first test cell is the CTS Rapid Set DOT Repair Mix. So the first photo here is from June of 2018. You can see there is a little bit of cracking present, but the entire patch is still in place, so this would get a rating of 3. And then the second photo from September of 2019, you can see those same cracks are there. The pink paint, we actually went out, Gordy went out and noted debonding within each of the patches out here. So the pink paint would be representing if the patch has debonded. So there is debonding here. But again, the patch is 100% in place. It hasn't had to be repaired, so it still gets a rating of 3. The second one, Spec Chem Repcon 928. This one we actually got a photo of the patch immediately after it was installed in 2017, so that would be where it was considered a 4. However, I did not get a photo of this exact same patch area in 2018, which would be a good sign because that means that it was doing well. But so in June of 2018, here we have a different patch in the same test section that there has been a little bit of cracking that has developed. So it got a rating of 3. And then again, in September of 2019, we can see that it still has that cracking, but no debonding, and the entire patch is still there. So it still has a rating of 3. The third one, Western Material and Design Fast Track 246. Again, here's a photo from 2017 being installed. So after it was installed, it got a rating of 4. 2018, no photo, which means it was doing well, no signs of distress, would have had a rating of 4. And then in September of 2019, we can see there's a couple of cracks and a little bit of debonding right at the joint, so a rating of 3. Next one, Western Material and Design, the CE 700 HPC. Again, a photo from installation date. So after it was installed, got a rating of 4. No photo from 2018, which means it was holding up really well. And then the second photo you can see from 2019, there's still no distress, no signs of distress, no debonding. It's holding up really well, so it still has a rating of 4. Next one, DS Braun Pave Saver Polymeric Concrete Patch. Again, installation date in 2017, it had a rating of 4. No photo in 2018, which is good. And in September of 2019, again, no signs of distress. So it also got a rating of 4. The Wilmette Valley Company Fast Patch DPR, again, installation, got a 4. No photo in 2018, which is good. And then in September of 2019, there was just a little bit of cracking right at the joints, and then a little bit of debonding as well. But the entire patch is still in place, so it got a 3. 5-star products, Rapid Surface Repair Easy Mix. So this first photo here is from June of 2018. So this would have been right after these patches had gone through their first freeze-thaw cycle. And you can see that there's just a little bit of material missing along the edge here. So it got a rating of 3. So then when we went back out in September of 2018, so still that first year, you can see that the edge of the patch here is really where the traffic was hitting it, and it ended up deteriorating quite a bit more. So it actually got repaired between June and September. So it wasn't quite 50% of the patch that was lost, so it got a rating of 2 at the end of 2018. And then when we returned again in September of 2019, the entire patch was repaired with some hot mix asphalt there. So at that point, we considered the patch to be failed. Another 5-star products, Rapid Surface Repair Epoxy Fix. So this first photo is from the installation date. And then in September of 2018, you can see half of the patch ended up popping right out, but half of it is still in great shape. So we gave that one a 2. And then when we returned in September of 2019, the entire patch had to be replaced, so that one was considered failed. Next one, TCC Materials Pro Spec Concrete Patching Mix. So here again in June of 2018, there was just a little bit of material that was missing from the edge here, so it got a 3. When we returned in September of 2018, there was quite a bit more material that had popped out there, so we did have to do some repairs between the June and September of 2018. And then when we returned in September of 2019, more material had broken out. There was quite a bit more cracking and some debonding. So this one actually had over 50% of the patch was had to be repaired, so it went down to a 1. The next one, aqua patch. So this one we actually got quite a few photos here. So this is all kind of the same area, just different angles. So this first one photo is the day after it was installed in 2017. And then you can see in June of 2018, the material, there's a little bit missing from the edges here, and there's some cracking, but less than 50% of it is missing, so it got a 2. Again, September of 2018, when we returned, you can see there's a bit more cracking, a bit more material is missing, but still more than 50% of the patch is in place, so it's still got a rating of 2. And when we returned in September of 2019, the entire patch had been replaced. So that one was considered failed at that point. Next, Craftco HP Concrete Cold Patch. This one I actually have 2 examples. This product is a little bit different. The first photo here is from 2017 when it was installed, or the day after it was installed. So you can see there was a little bit of material that got dislodged there. You can also see there's tire tracks in it, footprints. So it really looks like this patch maybe didn't get the compaction that it required. And it also looks, I mean, it's already kind of a little bit depressed already, so it could have been an issue just of lack of material that was available to put in this patch. So then when we returned in 2019, the entire patch had been repaired with hot mix asphalt. However, the cold patch did not, it's still in place, it's just that it was depressed to the point where it needed to be filled in more. So that is why there's the hot mix asphalt over it, just to fill in that depression. So that's where I gave a second example here. So the second example is the first photos from 2018. So you can see that they had that similar issue with compaction, where you can see that they put a second layer of that cold patch on top during the installation. So you can kind of see that there, but otherwise it's really holding up. And then when we returned in September of 2019, you can still see there's that layering there, but this section, since it got a second layer, it hasn't depressed quite as much. There's a little bit of cracking down the middle where the joint would be, but other than that, it's holding up pretty well. The next one, Craftco Techcrete TBR. So this first photo was from June of 2018. There was no signs of distress in 2018. And when we returned in September of 2019, it honestly looked almost exactly the same. So that's definitely good. The next one was TCC Materials, the 3U18 Modified. So this one, it's a common patch mix that MnDOT uses, and they modify this mix by adding 2 different admixtures. One is an accelerator and one is a water reducer. So this first photo from 2018, it's in pretty good condition here. And then in September of 19, There's just a little bit of cracking and a little bit of debonding in that one corner. The next one was USG EcoFix. Again, June of 2018. You can see there's just a little crack in the corner here. And then it's September of 2019. That is still the only distress that is showing up right now. So that same crack in the corner, which has also debonded. So the last test cell for the cementitious and polymeric material, we used that CTS Rapid Set DOT repair mix. So it's the same material that was used in the very first test section, but this time we added zinc coated fibers. So there's a photo from June of 2018. There was a little crack that developed right along where the distress line was. And when we returned in September of 2019, that's pretty much still the same. That same crack is there. There's a little bit of debonding that has happened, but otherwise it's holding up pretty well. So that was on, I believe, the driver's side, and then or the driving side, and then the passing lane side we used stainless steel fibers, so comparing the two different fibers. So in June of 2018, this one again, there was some cracking that had developed, but when we returned in September of 2019, it was just still that same crack that's there, but otherwise the patch is still holding up pretty well. And then, as I had mentioned, the last two test sections were just hot mix asphalt. And this area, there's been quite a few repairs. We still need to track down all the dates that these patches have been repaired over the last few years. So this photo from June of 2018, we're pretty sure this is actually material that had been replaced since installation in 2017. And then this photo from September of 2019, again, it looks, there's definitely some cracking along the edges here, and it's possible that this has been replaced since the installation. So next steps. So we'll have the final site visit this year. So after that final site visit, we will complete a patch condition matrix with that rating scale that we developed, and then also create an installation matrix for comparing the installation process for each of the different products. A final report is to be completed by April of next year, and I will be presenting on this again at the pavement workshop in May if all goes as planned. So yeah, does anyone have any questions?
We do have a few questions in the comment box here.
All right.
Did milling go deep enough to touch the base layer?
As far as I know, no. It did not extend beyond the concrete pavement. However, it is possible that it went below the half of the depth of the slab.
Okay. And then someone followed up with, or catch any dowel bars.
That I don't know. I don't think so.
Okay. Did you have any movies of the initial operations that Bob F. may have done? So like any video recording, maybe?
I personally do not have any videos. I can definitely look around and see if there are any.
Yeah, there may be some that we have our network files here. I know we do have a lot of recordings from April of 2017. I'm not sure if that's related to this project or not.
Okay.
So we can look into that further.
Yeah, maybe we could post some of those up on the website for this project.
Heidi?
Yep.
This is Mike Reidler from Dow. Do you at least have a table that you're going to be able to also include with the patch materials and the ratings on what their relevant materials properties were? Which ones were stiffer, which ones were more flexible, which ones had, higher thermal expansion, lower thermal expansion, just so that you might be able to find some general trends on the patches that seem to be more durable?
Sure. So part of the report is just including all of those material data sheets, but we could possibly include a table that just compares all of those in one spot.
Because my sense is that there's likely some kind of a difference between the ones that are quite stiff versus the ones that have a bit more flexibility, particularly in the climate zone that you're talking about.
Yeah, especially being the joint repairs where there's a bit more movement.
We have another question here. Who does the rating of the patches and how often do you look at them?
So I am doing the rating of the patches, so that try to keep that consistency there. It will be me throughout the entire project doing that rating. And how often? It's about once a year. So trying to keep it consistent. So we're doing the September of 2018, September of 2019, and then it'll be me again in 2020 when we do the review.
Okay. I'm just going to continue going down the list here and reading off these questions. If anyone else has a question that they'd like to ask, you can unmute yourself and go ahead and ask it as well. And someone had a specific question about the depth of the patch, and they were referring to patch 94006A.
Sure, let's take a look. So you're asking what is the depth of the patch. I did not measure the depth of the patch, but I know the goal was to stay within that upper 1/3 to 1/2 of the total slab thickness. So it would have been a couple inches.
Okay. And someone has another similar question. The 5-star product patches look very shallow. How deep were these repairs?
Well, okay, so let me go back to the very first photo of the installation here. So you can see the way they were milled, it tapers a little bit. So right along the edge of the patches there, it is pretty thin. It isn't just a right angle going straight down. You can see it tapers down. So each of the distress areas looked like this.
Okay. And we have another question here. Do you see any correlation of patch failure and not sandblasting?
Yes, that actually is something that we've noticed. So we did take note of exactly which patches got sandblasted and which ones didn't. And there are a couple test cells where it was the same product being used throughout the test cell, but sandblasting was only done in the driving lane and not the passing lane. And there does seem to be a correlation between the sandblasting the patches seem to be doing better than the areas where it was not sandblasted.
And a few more questions here from the chat box. Did the study examine producers or product constituents? I do not know if mentioning the product is as important to us as the components that govern those characteristics. What are the governing features of the products that did not perform well and those that did? Why were they not rated according to MnDOT's rating system?
So we will be comparing each of the products based on their components. For this, I guess for this presentation, I just wanted to provide a unique identifier, I guess. So the product name was an easy way to identify each of the different patches. And for the MnDOT rating system, we did use the MnDOT rating for the condition of the patches. I guess I don't understand that question.
Bernard, if you are still on, looks like you are. If you wanted to clarify your question here, you can certainly do so.
Yeah, the purpose of that question is to ensure that we maintain uniformity in our rating standard. There is definitely the way our pavement management does their rating with severity and occurrence of various distresses, and that's in our distress manual. So that's what I was aiming at, because severity and occurrences, there is a standard scoring system which our pavement management uses. So I don't know if reference was made to that in your scoring criteria, because that will make for uniformity and understanding of your scale of rating.
Okay. Yeah, so as far as the distresses go, I did try to stick to what MnDOT identifies as distresses. We did use a 0 to 4 rating scale here, but at the same time, understanding that we're rating just the patches themselves and not the entire roadway, which MnDOT would typically do. So trying to keep it focused on each of the different patches instead of considering the full length of each test section.
And I guess, Heidi, this is Ben Worrell speaking. Bernard, the TAP got together and talked about the rating scale that we'd use for just the patches. Again, a lot of the rating systems for the state deals with the whole concrete panel. So for these patches, we just had a consistent method of doing it. And each state does it a little different. So in a lot of ways, doing it to MnDOT standard is not necessarily the all true correct way of doing it anyways. So, as Heidi stated, there's the rating scale we used, and that really has helped us kind of separate the different products and methods that were used. So, I think if you look at the final report, this was just an overview. There's just a few pictures we could look at in this short time frame, but there's a lot more pictures and things like that on that NWRA project page.
Hey, this is Matt Zeller, Concrete Paving Association. Just had a couple comments. Again, if you go back to the very beginning of this job, and if you look at the NRA page for this effective, long-lasting PCC partial depth joint repairs for challenging conditions, the idea of this originally was to come up with something that would stay in a distressed, or concrete hole longer than an asphalt patch would. In Minnesota, again, you saw in Heidi's presentation one of those patches at the end where it was asphalt and had to be replaced how many times. Again, so the idea was to put something in one of these, artificially distressed holes that had minimal prep and would actually stay in the hole for a while. It would give the DOTs an opportunity to react, to say, okay, well, we need to schedule a project within the next 2 years where they wouldn't have to keep going out and replacing these patches. So again, kind of relating this back to pavement management rating and other such things, and what worked, what didn't, wasn't the original intention of this. It was to show that, one, that we can find some products, and then where do we go from there? So yeah, maybe that's the next step, is to start looking for the characteristics that that we can actually get a patch, a concrete or a cement based or some sort of patch material to stay in a hole for a few years, so that the DOTs don't have to keep coming back and replacing like they do with the hot mix all the time. Again, we tried to get the MnDOT to get some of these products out in place this past winter season. We got that started a little too late, so we didn't get that done. But I think what this does show is that there's some promising materials where the maintenance crews will not have to keep chasing a repair down every few weeks as we go through freeze-thaw cycles, or every couple of months.
Another thing I'd like to add, this has been Worrell again. When we started this out, we did some original stuff at Minroad before this study started, and we did it on actual partial depth repairs, and we tried a lot of different products. What the problem was is all the different patch areas were different, meaning that they're in different panels. This worked through NRA with the idea there was, when we created these artificial areas, they were then to match each of the products, so each product had kind of the same location. And so it's kind of an upgrade from the initial work that Tom Burnham and Eddie Johnson worked on at Minroad before this. And there's that report on the website also. The other thing is that we were working with Matt on doing an open house possibly in May to kind of look at these products, to get out and do a review. We'll do something this summer once we kind of figure out everything else that's going on. But that's the idea, is to kind of do that, and I think doing more videotaping and things like that would be helpful. So we'll be planning on that for later on this summer, and we'll be working with Matt on that. Thank you.
Ben, on what you just talked about, there have been 4 major initiatives now where products have been examined. One was done by Dr. Ishan when he was at UMD. Even when he had transitioned to New Hampshire, he still got it done right there. And he did find out that the slant shear test was very indicative or very predictive of behavior of a substrate a repair material on a substrate. That's among the major things he found out. And then there was the one that was done by Eddie Johnson, like Ben Worrell referred to, Eddie Johnson and Tom Bonham. And then we have this initiative that Heidi just reported on. And then finally, we did a strength at opening to traffic repairs. We had repairs in the strength at opening to traffic. So I just want to mention that when we now get together and look at all these, let us do a coalescence of everything that have gone into these initiatives, so that we don't reinvent the wheel, so that, like Matzela said, we can identify those products or those characteristics that actually make for sustainability in repair materials.
Okay, do we have any other questions from the audience? Okay, I guess not. So thank you very much, Heidi, for that presentation, and thank you all for joining us today. We will see you back here on April 21st. Have a great day.